بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على رسول الله سيدنا محمد وعلى آله وصحبه وسلم أجمعين وبعد. اللهم علمنا ما ينفعنا وانفعنا وعلمتنا إنك أنت العليم الحكيم. So we are still in chapter 14, partial derivatives, and in this section we're going to learn the chain rule. Chain rule is very important, as you know, in MATH201. And in this course, when you deal with functions of multiple variables, it's better to know how to do the chain rule in this case. So this is the chain rule in MATH201. If you have y as a function of x and x is a function of g, and the n variable is t. So if you want to differentiate y with respect to t, you're going to have it dy by dx times dx by dt. Okay, so you have it this way. And the tree triagram is like this. I mean, we in MATH201 we've never seen this before. We did not see it before because we didn't need it. But we're coming to more variables. This will make useful for us, very useful for us. So this is, we imagine the relation between the variables. This is how we imagine the relation to it. So we start with the dependent variable y, and y depends on x, as you see here, depends on x, and then x depends on t. So we draw arrows like this. Y depends on x and x depends on t. And then if you want to find derivative of y with respect to the end one, t, you have to find dy by dx times, this is, when we follow the arrows, we do the product. dy by dx times dx by dt. dy by dx times dx by dt. So this is what we get the result, dy by dt. Okay? So this is in MATH201. You know it in MATH201. طيب, in functions of multiple variables, things are different. Things are different here. So we have different scenarios and cases, but at the end we're gonna draw the general case, that cover all these cases. But just we want to understand step by step. So let's take the first case. Assume you have a function w is equal function of x and y and z, function of three variables, and x is a function of t, y is a function of t, z is a function of t. Okay, each one of these is a function of t. So imagine if you substitute back in w, y equal ht t, what is the last variable? When you substitute everything x and y and z, what will be the last variable here? What is the only variable you will have? It will be a function of anyone?
T.
T. There you go. So we have a function of t. Okay. So according to the chain rule, we have to do this. dy by dt, and notice how d is written. We are writing the full derivative. Why? Because the input, when you substitute x and y, z, it will be only t. W is a function of t. So that's why you put dw by dt, which is equal to partial w by partial x. Why we are writing partials? Because w is a function of x and y and z, and then times dx by dt. But we don't stop here. We have to do one for also y, and the other one for z. Right. Maybe this one we cannot remember it. So what we do what we call a tree diagram. So this is the dependent variable w, and if you notice here, w depends on x and y and z. So this is what we have here. We draw three arrows. It depends on x, depends on y, depends on z. And then x depends on t, is a function of t. So after all, x depends on t. Y depends also on t. Z also depends on t. So we can do this way here. X depends on t, y depends on t, z depends on t. And by the way, Shabab, you can do arrows, three arrows like this, below x, below y, below z, and put t, t, t. Also it works. Okay. So if we want to find derivative of w with respect to t, I have to look for all the paths, all the arrows leading to t, connecting from w to t, all the possible arrows. So you have one arrow like this direction, and like this, and like this. You have three arrows, three directions, or three roads to connect w to t. So for this arrow, we're gonna write it dw by dx, or partial w by partial x, and then times dx by dt, because this derivative with respect to one variable. And then you say plus the other arrow, partial w by partial y, times dy by dt, plus dw partial w by partial z times dz by dt. So we have this way here. The variables in the middle, we call them intermediate variables because they are between the first dependent and the last independent, because they are in the middle, getting between these two. So we call them intermediate variables. Sometimes, Shabab, we need to introduce these, and we have to write it down, the intermediate variables, but sometimes if you give it to me, that's fine. You don't need to remember the names. Type. We talked about a function of 3 variables. Now, of course, if you have function of 2 variables, if w equal fx and y, and x equal function of t, y equal function of t, then you follow the same rule, but you don't have this branch, the z branch here. طيب يا شباب, what about if I have x, y, z and another variable, call it k, whatever. What will be the difference here? But it's a function of t, by the way. What if I have a 4th variable? What should I do?
We should
yes, Abdullah?
we should add extra term.
Yeah, plus partial w by partial whatever, call it that, k or whatever, times dk by dt. So you can generalize the idea here, Shabab. Yani, inshallah, you have 100 variables in the middle. Then you have to say plus, 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 and so on, following the same way here. Okay, Shabab? So this is the case where the input, the last variable, we end with only one variable here. Okay. So just the same thing. Just I want to keep it in front of you, and let's solve this example. Find dw by dt, where w is 2x squared minus y squared plus 1, and x is equal to t squared plus t, and y equals square root of t at, he needs to find the value at 1. Okay. So let me show you here. I'm sorry, Shabab, you feel a little bit sick, not okay today, so maybe not so excited so much, or you will see my voice not good today, but I'll try my best. So now, so we have w is equal 2x squared minus y squared plus 1, and then you have x equal t squared plus t, y equal square root of t. So let's draw the tree diagram, Shabab. Now we have w, because he said find dw by dt, okay, at t equals 1. Okay, so let me make this figure. Yes, we can see here. So now we have w. How many variables that depends? The w depends on, I see x and I see y. Shabab, I'm doing this because later we're going to have different cases and a general case. So that's why even this basic example, I will do the 3, because later we're going to need it. Right, if you look at x, Shabab, there is only one variable in x, which is t. And y, there is only one variable I see, which is t. Okay, later we're going to see another variable here, so I have to draw another arrow here. Okay, right. dw by dt equals, so I have to go t here, and I have another road here. So in this road, I will say partial. Why? Because w is a function of 2 variables. So it is partial w by partial x times, I have to follow this arrow, dx by dt. So we have dx by dt, and I'm saying d, the usual derivative, because the x is a function of t. It's a function of one variable. Plus the same thing, partial w by partial y, and then dy by dt, which is equal. Now, partial w by partial x, this is it. This is here. So what is partial w by partial x, Shabab? Anyone? Raise your hand. I think it's simple.
4x.
4x. Mumtaz. 4x times, I will put between brackets, dx by dt. Look, Shabab, dx by dt. What is dx by dt? Yes, Muhammad Ahmed.
2t plus 1.
2t plus 1 plus partial w by partial y. Anyone else? Partial w by partial y. Yes, Abdullah Faisal.
Minus 2y.
minus 2y. So let me write it like this, minus 2y. dw by dt يا شباب. Where I get it? I get it from here, which is 1 over, I will do it here, this one, square root of t. So you have it this way here. Like, what is x, what is y? This is x and y, because we want to write it in terms of t, or you want to keep it, it's fine, because at the end he said evaluate it at t equal 1. So you have to find the value of this derivative when t equal 1. You can substitute every t by 1, but you will stuck with x and y. That means you have to go back and substitute here. Okay, so let's do it like this. For x, so we have 4t squared plus 4t times 2t plus 1, and then here minus with minus will go. And by the way, y is the square root of t, so it will cancel with the square root of t, so we get minus 1. يعني هنا أعطيك minus 1. Now dw by dt evaluated at t equal 1, so we substitute 1 here, so we have 4 plus 4, we get 8 times 3 minus 1, so we have 24 minus 1, so we have 20. Okay. Any question here, شباب? So things is clear. This chain rule is very nice, and this is the result. Like, this is a simple case of one variable. Now let's talk about the other cases here. Now assume you have w is a function of x and y and z. And x is a function of two variables, r and s. Y is a function of two variables, r and s. And z is a function of two variables, r and s. So imagine it's three variables, and each variable, the intermediate variables, is a function of two variables here. Then the chain rule will follow this way, because at the last input, it's a function, is a variable r and s. I mean, when you substitute every guy here, you have only two variables at the end, r or s. So I can differentiate w with respect to r and differentiate w with respect to s, and it follows this way. Okay, Shabab, please go and do the attendance quiz, Shabab. Please go and do the attendance quiz now.
Doctor,
Yes, yes.
do we have to memorize this question?
You don't need, because you will see the tree diagram will help you to write it down.
دكتور صلى على النبي ما انا وقفز.
طيب, okay. Just answer. We will talk about it at the end of the lecture, inshallah.
I don't know how to use the tree diagram.
No, we're gonna talk about it. I will do it here, but I'm waiting for the others to finish. خلاص يا شباب. So now I think you've done with the quiz.
Doctor,
Yes.
I don't
Yes.
see the quiz, okay?
معلش مين اللي بيتكلم؟
فهد.
ايوه فهد, ايش المشكلة؟
I don't see the quiz, just to know only, okay?
طيب, tell me at the end يعني that you cannot see it, okay?
Okay.
Okay. طيب. Or write it in the chat. Write it in the chat if I had. Okay. طيب. Yeah. So now we have this. Of course, as your friend said, we need to memorize it? No, we don't need to memorize it. Just by logic, we're gonna follow this tree diagram. So now look here, Shabab. W is a function of x and y and z. So that's why we draw an arrows. W, x, y, z. Inshallah, if you have 10 variables, put x, y, z, and list all the variables down and draw arrows connecting these, starting from the W and ending with these independent variables. And look at x, Shabab. X depends on r and s. Okay, so that's what you put here, r and s. Y depends on r and s. So we have r and s. Z depends on r and s. So I put two arrows r and s here. Okay. طيب يا شباب. Now I want to find the derivative of w with respect to r. Derivative of w with respect to r. How many roads starting from w I will end to r? I have one road like this, and I have one road like this, and I have one road like this. So I have 3 roads. 3 طرق اوصل من ال W لل R يا شباب. So you have 1 2 3. So then you're gonna say this derivative of W with respect to X, partial W by partial X times لما connect 2 arrows you need to multiply partial W by partial times partial X by partial, which is this term. Then you say plus partial W by partial Y times partial Y by partial R, which is this, plus partial W by partial Z by partial R, which is this. And similarly, you will do for the S. You do for the S. So you don't need to memorize this. Draw the tree, and you will get it right away. Right. If you have a function of 2 variables, and each one depends on 2 variables, you still have this, but you don't have the Z part, so you don't have the Z part. You also can draw a tree diagram corresponding to this situation. Even if you have 100 variable in the middle, you can do the same way. So let's do this example. Okay, let's do this example. Find partial W by partial S and partial W by partial T if W is equal to EXY plus Z, X equal S plus T, Y equal S minus T, Z equal E squared. So he said find partial W by partial S and partial W by partial. Right? So not evaluated at a certain point, you need to find them as a function. So what we do is we draw a tree. Okay, the tree, because he said DW, so start with W. And then how many variables inside the W? Okay, here should be in the center of the camera. Yeah, so how many variables you have? I have X, Y, Z, 3 variables. So we have X, I have Y, I have Z. And then X depends on what? I see here, X depends on S and T. So we have 2 variables. One is called S and the other one is called T. So look at the W. W depends on S and T. So also depends on S and T. Z يا شباب depends on only T. Only T. So we have 1 arrow and I put T like this. خلاص يا شباب. Now let's start with this one. Partial W by partial S. How many ways to connect from W to S? نشوف هنا يا شباب. دي واحدة. هذه 2. I have 2 ways to connect from W to S. So let's represent this way. What should I say يا شباب? Anyone? Yes, Rakan is here. Yeah.
partial W partial F.
Partial W by partial معلش.
X.
X. بعدين.
partial X partial S.
Partial time partial X. This is a product, huh? Sure.
Yep.
Okay, very good, Rakan. Plus. أيوه.
partial W partial Y. Partial Y partial S.
Partial S. Okay, and that's it because you don't have S branch here. Okay, you don't have S branch. Very good, Rakan. So we continue with this one. Now partial W by partial X, what is it? This is W. This is the equation of W. So what is the partial W by partial X for this one, Shabab? Anyone? Faisal, تفضل Faisal.
It becomes E SY
The same times
times the
derivative with respect to X. So
E Y times the
derivative of the power.
yes, X becomes 1, so and the Z 0, it's E SY.
So multiply by
Y.
Y. هذا اللي مستني من زمان. Okay. Now times dx
Times
by
the,
ds.
Yes.
What is the derivative with respect to s? هذا هو. I get it from here, which is 1.
1.
Okay. خلاص. So I say plus. طيب, thank you, Faisal. Now dw by dy. Who gonna find me the derivative of this one? Yes, Muhammad Sultan.
X times a to the power xy
Yes.
plus c
Yeah, times
times x.
x. Very good. And then dy by ds. What is it?
1.
1. So I have this guy here. Okay. And I'm done. I'm done with this one, but you can take e x y plus z times, if you take e as a common factor, you have x plus, so we have it this way here. طيب يا شباب. Now partial w by partial t. Now how many ways I get from wt يا شباب? How many ways I can go?
3.
Okay, very good. Yeah, 3 ways. So we have 1, 2, 3. That means I have 3 terms. Okay. So the first way I can do it here, partial w by partial x times partial x by partial t plus partial w by partial y by partial t plus partial w by partial z by partial t. Okay, and then you just substitute here partial w by, you see Shabab, partial w by partial x, the same thing as you found it here, you will find it here. So this is the answer that we found, ex y plus z. Partial x by partial t, here will make difference now, huh? هنا طبعا 1, so we don't have any problem. But here dy by dt is negative 1, so we start with negative. Partial w by partial y, which is the same as what we found it here. But also you have to be careful, يعني. And then this is the term that we did not find in the beginning. So plus partial w by partial z يا شباب ايش يعطينا؟ Anyone? Partial w by partial z. عقيل. تفضل عبد الرحمن عقيل.
we'll give us E
The same times
times 2t.
2t. Okay. طبعا derivative the power derivative power is 1. خلاص نروح على طول على الثاني اللي هو partial z by partial. So we have it this one here. And you can say this is equal exy plus z because it's the same times y minus x plus 2t here. Okay. Of course يا شباب يعني you can write it يعني x what is it, y what is it, xy plus z, write all these guys if you want. Okay, the same thing. You can write, substitute every x, y, z in this last expression by these equations here. You can do that. It depends يعني on the problem. Okay. محمد سلطان تفضل.
وليش نسوي كذا يا دكتور؟
What do you mean?
يعني وش الحين احنا نطلع الدي واي باي وش
You mean
الفائدة؟
what is the why we need dw by ds?
ايه
Because sometimes it depends on the problem. You have a function, depends on variables, and the variables depends on something else. Depends on time, for example, and space. مثلا x depends on time and space, and x represents something, some physical problem, physical phenomenon. Okay, y the same thing, z the same thing. So you want to differentiate w with respect to the time. How many ways? You have to go this. خلاص? You want to find the rate of change of w with respect to s, for example, the change in s, or the rate of change of w with respect to t. Okay, شباب? Okay, محمد?
دكتور, so partial W partial T or S. Three ways. No, I can't do it in one way, right?
What do you mean by one way? I don't understand you.
I can't write dw by dx and dx by ds and stop.
You mean, for example, if I want partial w by partial t, I will do this?
Yes.
No, it's not correct. You have to find this.
Okay.
Okay, inshallah, if you have 100 variable, you have to follow all the paths connected to t. Okay? طيب يا شباب. Just a moment يا شباب. Okay, sure. So this is it, and these are the final answers as we get them. I wrote them y, x, y, but you can substitute x, y, and z, the respective here. You can substitute here if you want really the last output is in terms of S and T. Okay. Now let's talk about the general version. I put case 3, but it is the general version, and it covers all what we said before. Now the general version is this. The chain rule, suppose that u is a differentiable function of the n variables, x1 up to xn, and each xi or xj is differentiable function of m variables. يعني مو بالضرورة عدد الفاريبلز في الأخير تساوي عدد الفاريبلز اللي في الوسط، يعني الدنيا is arbitrary variables. Then if you want to differentiate u, then u is a function of t1 and tm, and then if you want to partial u by partial one of these t's, okay, let's pick ti for example, then it is partial u by partial x times partial x by partial t plus and so on. And so on, you go with this way here. So if you go back to the tree, Shabab, if you have w with many variables in the middle, and each one depends on different variables. X depends, for example, r, s, and t. W depends on different number of variables, and z depends on different number of variables. Then you can find the derivative of y with respect to any one of these variables of the last one by following the paths. Okay, so let's illustrate with this one. Write out the chain rule for the case where w is equal a function of x, y, z, and t. So we have 4 variables, and each variable, let's say, depends on other 2 variables. So x depends on u and v, y depends on u and v, z depends on u and v, t depends on u and v. Actually, this one, Shabab, I think I made a mistake here. I meant this one. Okay. So if you draw the tree will be like this. W depends on x, y, z, t. Look here, depends on x, y, z, t. بعدين x depends on y and v, u, v, sorry. Y depends on u, v. Z depends on u, v. T depends on u, v. So you have this tree. Now, how many partial derivatives I can find for w? I can find w with respect to u, and I can find partial w by partial v. Only I have 2 partial derivatives I can find with respect to w at the end for the last outputs here. Okay? So this is partial w by partial u. You follow this branch, this. So we have 4 terms which are written this way. Partial w by partial t, which is this one, this one, this one, that one. So you have it this way here. Okay. Any question here, Shabab? Yes, Muhammad.
If the questions find the second partial,
that will be another story, because the partial w by partial u, you put it here. تحط مكان هذا الw، تحط partial w by partial u. Partial w by partial is a function of also these variables. Okay. تبدل بدل الw تحط هذه partial w by partial u. Put it here and then draw the same tree. Okay. طيب. Now let's solve this example. This one. The question says, assume that w is equal function of Sn like this, and f prime of x is equal ex squared, find partial w by partial d, partial w by partial s. Now, so you have this w, a function of s cubed plus t squared. Okay? And he told you that, wallahi, this derivative of f at x is equal ex squared. He didn't give you the function f, but he told you what is the derivative. Right. So he asked me to find partial w by partial t and partial w by partial s. Right. What we do first, Shabab, to draw the tree diagram. فنحط التري يا شباب. أول شيء نبدأ مين؟ نبدأ بالدبليو. Okay, also because he asked me for partial w. How many variables depend on w, Shabab? Depends on. How many variables depends on, Shabab?
2 variables.
2 variables. So you have s, and then you have the other variable, which is t. Okay. And then what? Now here يا شباب, you don't see any paths, anything, and you're gonna say partial W by partial S T, that's it. You don't have anything else. So what we'll do, let me do it here in blue. We need to introduce an intermediate variable. مش نسهل علينا يا شباب الحساب او make it easy for us. Let's introduce an intermediate variable. So we'll say, for example, let pick any name. So let's call it U equal the middle. SQ plus T squared. So W is equal F of U and U is equal SQ plus T squared. Okay. Now let's draw another tree يا شباب, which is a refined or a better tree. Now W depends on, according to this way here, U. And U depends on two things now, because if you read it here, it depends on S and depends on T. And now things is better now, better than this way. This way we stop, we cannot do anything. Now let's find partial W by partial T. Partial W by partial T equals. How many ways we can find? It is only one way, but now this is clear. So we have partial W by partial U, or actually you can say dW by du. Why I'm saying dd? Because if I look at it, you look at it as one variable. If wallahi by mistake you put partial, it's fine, okay? But that's what we have here. And then U is a function of two variables, so we have partial U by partial T, which is equal to. Okay, let's do it here now. Now what is dW by du, shabab? dW by du. What is derivative of f?
F prime.
F prime of u. Very good. F prime of u. نحط F prime. ما أعرف مين هي ال F يا شباب. I don't know who is F, so I will write F prime. يعني whenever you have a function F, it will be the derivative. طيب, times partial u by partial t, partial u by partial t. This is u, so derivative of u with respect to t is times 2t. Okay, which is equal to. Now, what is f prime of u? Now, let me just put the paper a little bit this way. Look here. He told you f prime of x is ex squared. So, what is f prime of u?
EU squared.
EU squared. ممتاز. Times 2t. Okay, which is equal to 2t e. Now, take u out and put this variable, because he gave you in the beginning. So this will be SQ plus T square all square, because we are saying all square. So we have it this way. Okay. So we introduce a new variable, intermediate variable. الفاريبل اللي جاي في الوسط بين ال W وال ST, and put it here, and then just follow the branch. We have only one branch, so that's why we're able to do it. Here you will stop. خلاص, partial W by partial, and then what? Yeah, and he didn't give you the function there. طيب, now remember that we need to find the partial W by partial S, so we follow the same way. We follow the same way here. So partial W by partial S is equal to, if we follow the branch here, it will be dW by du times partial U by partial S, and this will be f prime of u. هذا ما راح يتغير. هنا التغيير when u is here, so we have 3s squared. And remember that this is e u squared times 3s squared, and this is equal to 3s squared e s cubed plus e squared all squared. Okay, I just substitute u from the previous one. Right, and that's it. Any question here?
دكتور.
Yes, عبد الرحمن.
بس انا ما فهمت احنا ليش حطينا اليو الجديده هذه؟ يعني ايش المشكله؟
Without, try to solve without you. Just think about it. Try to solve without you. يعني don't without introducing you. Try to solve it يعني. Okay. Like you may use, maybe some of you may think, okay, I will use like math 101. يعني I will say f prime evaluated at the inner times the derivative of the inner, but now you will say with respect to t, so you're gonna say times 2t. Yes, you can say something like that, and then you need to substitute instead of x, you need to substitute for this particular example. بهذا المثال you can say this, okay? But actually, it's nice to do it this way because you in future you get confused. يعني. طبعا لما اتكلم future, I'm not talking about only this course يا شباب. I'm talking about future in your career because you're gonna deal with a lot of variables. Yeah? So it's better to, sometimes it's nice if you introduce some intermediate variables. So now assume that in another example, w is equal to a function of, now here you see the comma, so it's a function of two variables, s squared minus t squared, comma, t squared minus s squared. Show that this identity or this equation holds. T times partial w by partial plus s partial w by partial e equals to 0. So now let's do it. I will write just here the question. Sorry, s squared minus t squared, comma, t squared minus s squared. And he said show that actually you can use this notation, that notation. We took it all of them. كلنا نعرف notations now. Okay. So now show that. To show an equation يا شباب, you know that we start from the left-hand side, for example, to end with the right-hand side, or start from right-hand side to reach the left-hand side. So we will start from the left-hand side here, because we have something here. So now we have w, derivative of w with respect to x, derivative of w with respect to t. Now this is w. S and t is inside and some function f that we don't know who is that function f. So here we introduce, we let, now we have one variable here and another variable here. So let, for example, x equal s squared minus t squared. طبعا عشان ما استخدم x يا شباب, I can call it x or u or v or whatever. T squared minus s squared. So now w is a function of, now I take this guy and put x here, I take this guy and put y here, okay? And s is equal x squared minus t squared, comma, y equal t squared minus s squared. When I draw a tree diagram, w depends on x, depends on y, and then x depends on, okay, sorry about this, depends on s, depends on t. The same thing here. Okay, I have the s. Now, I need to find partial w by partial s, or ws, which is equal to, now this is one branch and this is another branch. We have two rows. Huh? So here you can say partial w by partial x times partial x by partial s plus partial w by partial y by partial s, which is equal to. طبعا هنا يا شباب ما الله أعلم ما أعرف إيش هو partial w by partial because I don't know who is the function here. Okay. So I'll write it as it is. What is partial x by partial s يا شباب? 2s. We have here 2s. Now, the same thing يا شباب. Partial w by partial y, Allahu A'lam, I don't know who is it because they didn't give me part. And this partial w by partial s, it is minus 2s. Okay? Minus 2s. هذا بالنسبة للws. Now wt يا شباب, it is equal to partial w. Now we have one branch, you have another branch here. Partial x by partial t, plus partial w by partial y by partial t, which is equal to partial x by partial t, so we have minus 2t, and then this guy, I don't know who is it, so I will write it like this. And then here you have plus 2t partial w by partial y. So I have this guy and I have this guy here. Now let's fulfill the left-hand side of the equation. So the left-hand side equals, طبعا هذه يا شباب left-hand side. What is left-hand side? TWS plus SWT which is equal to, now I will multiply t times مين يا شباب؟ هذا اللي بنحسبه. We have 2s partial w by partial x minus 2s partial w by partial y plus s times this guy, oh sorry, yeah, this guy wt, which is this guy here, minus 2t partial w by partial x plus 2t partial w by partial y. طبعا يا شباب اظنها واضح الان، لما اضرب هذه هيختصر مع هذه صح؟ هذه will go because this is minus a plus and you have the same component. وهنا يا شباب لما تضرب t multiply by t minus 2st and here we multiply, so you have plus 2st, the same thing, this will cancel, so you get 0. Okay, and that's it. Once you reach 0, this is the right hand side. واضح يا شباب؟ Okay. The third example, you do a similar way. This is a function f u v w is a differentiable function. U is this, b is this, z is this. Show that you have this way here. طيب, at least let us draw the diagram, the tree diagram for this question. خلينا نرسم التي diagram وبعدين تكمل. ايش حنقول التي diagram here؟ او tree diagram هذه. طبعا هنا حتقول let، اسهل عليكم شباب، خلينا نقول مثلا actually let's call it f يعني حتى هو يعني let's call it f start with، ولا حتى تسميها يا شباب I don't know call it f psi مثلا، let f psi equal f of u v w. This is a Greek letter f psi يعني you can use it as a function. فالآن يا شباب when you throw the three diagrams, the f psi or f if you want depends on what? Depends on three variables, which is u, v, w. بعدين u depends on what يا شباب? Look at the question down.
X and Y.
X and Y. X and Y. طب v?
Y and Z.
Y and Z. W?
Z and X.
Z and X. So now you have a different variables for each one, huh? But there is a common, yeah, of course, between them. طيب يا شباب, now he said show that this equation. Now fx, if I want to differentiate f or f psi x, the same thing يا شباب, which is equal to هذه نفسها f يا شباب, هذه نفسها. كيف حوصل x يا شباب؟ كم طريق عندي؟ I have two paths. اثنين, yes, two paths exactly. طريقين هنا وهنا, اوكي؟ فنمشي الطريق هذا يا شباب, ها؟ هذا الطريق ايش يصير؟ partial f or partial psi if you want by partial يمر بالu, بعدين times partial u by partial x plus the other road is partial f by partial this one w times partial w by partial x. Okay, and you continue. And you say you do the same thing for this guy and for this guy. And you add them together. Of course, you don't know who is f, so you keep, for example, this one you keep it as it is. This is the one who changes because here partial u by partial x. You have it. He gave it to you. What is u? Partial u by partial he gave it here, and so. Okay. Any question here, Shiva? So as you see now, using the tree diagram, make it very easy for us to follow the chain rules here, okay? So we don't need to remember the expressions. خلاص, draw the tree, you are done. Okay? طيب. Now, let's talk about the implicit differentiation here. In MATH201, we know how to find the implicit differentiation. Actually, it looks like this way. You will have an equation, f, x, and y, a function of two variables, which is equal to 0. This is what we did exactly in MATH201. Huh? Defines y implicitly as a differentiable function of x, that is y equal f of x. Then, by the chain rule, we obtain something. Now, in MATH201, I don't want to show it because what we're going to do it here actually different, a little bit different. What we do is we differentiate every term, right? but every time when you differentiate y, multiply by y prime. Yes, this is what we used to do in Math 101. Now here we're gonna show you another way to do it. Another way to do it, and actually using partial derivatives, and we have a formula. We have a formula. Put it, substitute. Salam alaikum. That's what we get. So by using the chain rule, Shabab, make sure that you are saying equal to 0. So now when you differentiate this guy with respect to x, you look here, you have two variables. So we have partial f by partial x times partial x by partial x. This is what you will do, plus partial f by partial y and dy by dx, because y is a function of x. So you have it this way, and this is equal to 0. So what is derivative with respect to x? This guy, Shabab, equals what? لكم يعطينا 1. Very good. So we have only partial f by partial plus partial f by partial y times dy by dx. انا ابغى هذا يا شباب، انا ابغى dy by dx. ابغى dy by dx. كيف اسوي يا شباب؟ حودي هذا الطرف الثاني واقسم على هذا. لكن when you divide by this guy, make sure that it is not equal to 0. So this is what you have. dy by dx is equal minus partial f by partial x over partial f by partial y, or simply you're going to say minus fx. So this is a way to find the derivative using or to find implicit differentiation using partial derivatives. Of course, you cannot take this in Math 101 because we have to talk about partial derivatives and so on. This will take one lecture and a half in case UTR, to talk about partial derivatives. What do they mean and so on. But before partial derivatives, we have to talk about functions of several variables. You see, you need a lot of things before we talk about the partial derivatives. But in terms of calculations, yes, it is nice and easier to do it. So, for example, find y prime if we have this way. Now, if you give it to Math 101 student, he can do it in his way. But let's do it in our way now, a newer way. So let us find the y prime. Okay, and let me write the equation equals 6xy, and he said find y prime. Okay, طيب. Let me maximize this and let's do it. So ايش نسوي أول حاجة شباب؟ Remember that y prime اللي هي dy by dx equals minus f of x over f of y. طبعا عشان تتذكروا شباب y تحت والx فوق، تعكس الفاريبلز هنا، تعكس الفاريبلز، فهذه هي الفورمولا. Okay. طيب. But first let's define the capital F. So here, how to find the capital F? Make sure rewrite the equation to be equal to 0. So either move this guy to the left side or move this guy to the right hand side. Okay. So here we say let f of x and y equal to, مثلا, let's move this guy to the left side here, for example. So we have this minus 6xy, and this is equal to 0. Okay. So let's assume this is the function f. Okay. And then y prime equal minus fx over fy, okay, which is equal to minus. Now, derivative f with respect to x, شباب, what will be? What will be?
3x squared.
Yes. With respect to x, huh?
Minus 6y.
Minus 6y. And then with respect to y, شباب, 3y squared minus 6x. Okay, minus 6x. And if you put the minus here, so you have minus 3x squared plus 6y over 3y squared minus 6x. And you are done. طيب. If you want to follow like the Math 101, what are you gonna say? هذه بس أفكار Math 101. إيش كنا نقول؟ كنا نقول إيش؟ ايوه كنا نقول 3x squared plus 3y squared times y prime يساوي هنا برودكت رول يا شباب. ايش تقولوا؟ كنا نقول derivative الاول 6 ضرب الثاني زائدا 6x times derivative the second which is y prime. بعدين ايش نسوي؟ نرتب ال y prime في جهه فتصير 3y squared minus 6x y prime equals وتودي هذا الجهة الثانية فيصير 6y minus 3x square. فلما تقسم الطرفين ايش يصير يا شباب؟ minus 3x squared plus 6y تقسم على هذا. You see? The same answer. The same answer you get. Okay? This is using the ideas of Math 101, but this is a new way to, by a formula, just substitute the formula and you get the answer right away. Which one is easier, Shabab?
New way.
This new one, right? So some of this one, it'll give you directly the answer. Gives you directly the answer. طيب. Okay. Some of you will say, why you did not teach us this in Math 101? Well, as I told you, you need to talk about what does it mean, the partial derivatives, and then we have to talk about the function of two multiple variables. We have to talk a lot of things to reach this level. Okay. طيب. So we have this way. But of course, there is a common factor. Didn't take it here in my solution. So you can take 3 as a common factor, divide 3, and you will get this answer. Like, now let's talk about the implicit differentiation. If you are dealing with a function of 3 variables, and the last one, z, defines z implicitly as a differentiable function of x and y. Yani z is a function of x and y. Okay. How we can implicit differentiation this guy? The same way, Shabab. You follow the chain rule, but here you have 3 variables. So we have partial by partial x by x, and then yx, and then zx. Of course, you can do another one with the derivative with respect to y. So we have these 2 equations. But look here, Shabab. Before bringing another one, partial x by partial x is 1. Partial y by partial x is, what is the value of this derivative? Partial y by partial x. هذا الشباب, the one I'm pointing now. What is the derivative of y with respect to x? طبعا y and x, they do not depend on each other. So what is the derivative of y with respect to x?
y prime.
y does not depend on x يا شباب. y في حال سبيله, x في حال سبيله. What is the derivative of y with respect to x? y is like a constant to x. سهل عليكم.
dy over dx over
y is like a constant. انتبه يا خالد. y is like a constant with respect to x. So what is the derivative of y with respect to x?
0.
Zero. هذا الترم ما عندي. ايوه هذا الترم ما عندي يا شباب. I don't have it. Yes, I don't have it. Derivative of y with respect to x is 0. Okay. The z we keep it because z we are saying here implicitly as a differentiable function of x and y. Z depends on y, so we keep it. Okay. This one is 0, this middle term is 0, and this is 1. The same situation here, this is 0, this is 1. And then you divide by partial f by partial z, so we get these 2 formulas here. Partial z by partial x, which is minus, partial by partial over partial f by partial z, and other one for y. Okay. طيب, do you have something, Abdullah? Want to say something? وليد, عفوا. تفضل يا وليد.
دكتور اعتذر منك بس partial y by partial x ليش 0؟
Because y does not depend on x. Y is a variable, x a different, 2 independent variables do not depend on each other. Okay. زي ما تقول derivative of x with respect to y 0. يعني هذا اللي احنا قاعدين نسويه في المسائل, صح ولا لا؟
ايه صح.
So this is what you have. طيب. And the same situation here, derivative of x with respect to y is 0. Okay. طيب. So we have these 2 formulas which is similar to what we did before. نفس الشيء اللي هنا شباب. تحط y تحت و x فوق. هنا just change order values. Put z down here and x up here, and that's it. Or you can say minus fx over f. Now you can solve this equation. Find partial z by partial x and partial z by, if the equation is given this way, defines, and he told you that z defines implicitly as a function of x and y. So we can have it this way here, and let me minimize, put a smaller screen here. Let me write equation. So you have z cube minus xy plus, don't worry شباب, I will raise this up. Okay, and he told you z is a function of x and y. Okay, and he asked you to find partial z by partial x and partial z by partial y. Okay, طيب. Now what we do first, this is the first step. خلينا نذكركم هذا هو الفورمولا minus f, طبعا حبدأ بتحت بعدين ابدا باللي ثاني فوق وهذا الفورمولا الثاني y f z. Okay, so I need to define f. What is f here? What is the function f يا شباب؟
ننقل الواي
ايوه very good Khalid. So we take this to the left side or take this to other side. على كيفك. It doesn't matter. The answer will be the same. So we have this guy minus y cubed plus 4. Okay, you have to make it equal to 0. You have to arrange the equation. Now, if you want to find this guy here, يا شباب, minus fx over f, sorry, not fy, z, which is equal to, now differentiate with respect to x. So we have this 0, and here you have derivative with respect to x, so you have minus y. There is no x, 0. There is no x, 0. There is no x, 0, so you have only minus y. And then derivative f with respect to z. Now I have a lot of z's. I have two z's here. Right? So derivative with respect to z here, so you have 3z squared. And here you have plus y squared. Okay? Plus y squared. So this is partial z by partial x. شباب. So you can take the minus, so you have y over 3z squared plus y squared. Okay? Now let me just put this guy. Partial z by partial y is equal minus fy over fz, which is equal to minus with respect to y. If you look here, شباب, you have minus, and then you have 2yz minus 3y squared, and the form is z. With respect to z, شباب, the same denominator actually. So you have 3z squared plus y squared. Okay. With a minus, you can change the minuses inside. So I leave this to you. Okay. And that's it for the same thing that we found it here. These are some old exams. Please, Shabab, you will find now attendance quiz. Go do it. So I collected some old exams here. For the chair role.
What's the answer for these questions?
Sorry, Muhammad. I did not understand you, but there is a attendance quiz, I think.
I say, what's the answer for these questions?
Part A. Oh. The correct answer is A.
Doctor, there's no attendance quiz.
No,
في
it's
attendance quiz.
no, there is one. Sorry. It should show up now in any moment. Still, no, it should show up now, شباب. Okay.
I don't have it.
الحين
ما طلع علي أنا بعد.
طيب yeah, I know if I did something wrong here. طيب. But anyway, it may appear in 2 minutes from now, but it's fine. If you didn't do it, maybe there was a problem with this quiz. But anyway, Shabab, so think about these questions. Think about them, how to solve them. I think you can follow the tree, the diagram, everything. But in this question, Shabab, look here. In semester 191, he gave you an equation and he asked you to differentiate y with respect to z, but he didn't tell you anything about the relation between y and z. So you should understand that y is a function depending on z and the other one, which is x. So think about this way. So you have to use this implicit differentiation here. Okay, you have to use here implicit differentiation. Yes.
الخطوات يعني يحصل الإجابة نحصلها في الموقع. Math?
Yeah, I picked up these from the math. No, without steps, like this. Question, the correct answer is A, the master version. Okay, master version. But I want you to think about it, yani. Instead of me solving it, I want you to think about it. If you don't know how to solve any of these questions, you can reach me, and we'll see it together. Okay, sure. طيب. Now this is for this section, and I want to talk about the other section. I have, I know I have time, so let's get to it now, because it's a nice section. Now, in the section 14 point, actually this is 6. I have a mistake here. 0.6. Right. This section, Shabab, is about the directional derivatives and the gradient. So we have two things. Actually, there are three things in this section, but the main two things are the directional derivatives and the gradient vector. Now, the gradient vector, you're gonna see it a lot. If you are a mechanical engineer or electrical engineer, you're gonna see this a lot in many courses. For the other engineering students, I don't know if you ever see it or not, but in all those two, we're gonna see it a lot. So if f is a function of two variables, x and y, then the gradient of f is the vector function del, this is we read it del f or grad f, you can pronounce many ways, defined by this gradient f x and y is equal, this is a vector, Shabab. If it's two dimension, we put it two dimension. The first component is the derivative of f with respect to x. The second component is the derivative of f with respect to y, which is equal partial by partial x in the direction of I plus partial f by partial in the direction of j. If you are dealing with function of three variables, the gradient of f is giving this way partial derivative of f with respect to x, derivative with respect to y, derivative of f with respect to z, and you can write it in terms of I, j, k. So when you take the gradient of the function f, the result will be a vector. The result is a vector, keep in mind. Gradient of f will give us a vector, okay? Later we're going to talk about what does it mean in the plane, where we can see. Right. So let's compute the gradient of this function in the indicated point. So we want to do this one. What is gradient of f? Which is equal to derivative of f with respect to x, derivative with respect to y, and I am dealing with function of two variables, so I'll stop here. Which is equal to, what's the derivative of f with respect to x? Two square root x cubed y minus y to the power 4 times, ايش راح يكون هنا شباب؟ Derivative with respect to x, so 3x square y, another one we don't have it, and then comma, the same thing is about 2 square root x cubed y minus y to the power 4 times the derivative with respect to y. So what is the derivative inside the root?
X to the power 3
minus 4 cubed. Right. Now we want to find the gradient of f evaluated at, he gave me the 0.32. What should I do? I replace every x by 3, every y by 2. So we have 3 times 3 square times 2 over 2. يعني here 3 cube times 2 minus 2 to the power 4. Just compute.
assignment quiz جاء طلع.
طلع. طيب يلا please do the assignment.
بس يقول he is not responding.
يقول لي not response.
خلاص leave it يعني because I just leave the quiz يعني هذه I will delete it or ignore it يعني. Okay, this quiz. So don't worry about it. خلاص, there was a problem with this quiz. طيب, so this is the gradient, how we do it, and how just substitute and you will find a vector here. And the vector, and the answer is this one. You see, it is a vector 27 over square 38 in the direction y minus this. What does it mean this vector in the plane has a relation with this function? We're going to talk about in the coming lecture. The last part is, or the second part is the directional derivative. What does it mean and why we need it? Remember what we took in section 14.3, the partial derivatives. the partial derivative of x with respect to x of x naught and y naught is equal to this limit. We have seen this before. And we can think of it as the rates of change of z, the function z is equal to, in the x and y directions, that is in the directions of the unit vectors I and j. So if you remember what we did, that if you have a surface, okay, and you have a point on the surface, and then let me bring the software actually. This is what we did before, okay? So you had some surface, the same curve that when we talked about the partial derivatives here, okay? Right. Yeah, it's a bit laggy here. طيب. Yeah, maybe if I left it idle, it will freeze. You may experience like this in this software. Right. Anyway, that's what, if you remember this point A, شباب, when we talked about the partial derivative with respect to x and respect to y, قلنا نرسم plane يمر بهذا النقطة parallel to x axis and plane parallel to y axis, then you have an intersection plane, okay, which I cannot click it, and then we said, well, the derivative of f with respect to x is the slope of the tangent line in the plane. Yeah, alhamdulillah, now it works. Okay, so remember, this is the, let's say you have a surface and you have a point on the surface, وقلنا نبغى نتكلم عن partial derivative with respect to x. كنا نقول ايش؟ نخلي البلين y equal بالضبط parallel to the x axis, and then you will find the intersection of the plane like this, and then we said wallahi it will be the line, right? The line parallel to this plane, and that's it, right? And the derivative with respect to x, it will be the slope of this line, right? طيب. So basically what we did, we find the derivative in the direction of يعني x axis here, right? The direction of x or direction of I here, the red one, if you think of red as x axis. The same situation if you found it in the direction of y. This is what we did. This is derivative with respect to y. Okay. So if you look at these two planes, one in the parallel to x axis and one parallel to the y axis, right? Now what about if I want a plane like this. شايفين يا شباب؟ في plane جديدة كده جاي في النص. I want to find derivative, the tangent line, but in this direction, not in parallel to x axis, not parallel to the y axis. Okay. So let me hide these. I want this. Okay. What will be the derivative or the rate of change of the function of the surface in this direction? In this direction, how to do it? So we put a vector down. Actually, not this vector. This vector, not this vector also. This vector. So we have vector here. So we put a projection of the plane in the xy plane here down in the ground. We put a vector u and make u is a unit vector. So we're gonna refine our statement that I want to find the derivative in this direction of u. أنا أبغى في هذا الدايركشن. ما أبغى في هذا الدايركشن زي ما كنا نسوي. ولا أبغى في هذا الدايركشن. I don't want this direction. هذا الدايركشن with respect to y. I don't want this and I don't want that. I want this. Anything in between. So what we're gonna do, inshallah, next lecture, we're gonna write the derivative or the general derivative that covers the derivative with respect to x and derivative with respect to y. This will be a special cases of what we're gonna do in future. So this is it. I want to find derivative in any direction in between x and y here. Okay, and we're gonna see that the formula is this, and we're gonna give it a different name. We call it capital du of x naught y naught, and it is equal to this limit. Actually, I don't need to prove it. Just to tell you this way. If you need to how he got it, you can follow the textbook. And there is a way to compute this directional derivative, which is this way. If I want to find directional derivative of f in the direction of the and this is very important, Shabab, direction of the unit vector u. You have to make that vector unit. If it's not unit, I have to divide by its magnitude. Okay, so the magnitude of this vector should be 1. So if I want to find directional derivative of f to this direction of u, I have to follow this formula instead of computing the limit. Of course, this is easier, or it's easy to remember that is gradient f dot u. Gradient f dot, the dot product, u. U is a vector, gradient is a vector, so we have vector dot vector, and which is this way here. And assume unit vector is having these components a, b. The gradient, we know who is the gradient, which is f x and y, like this way here. So if you have 3 variables, we do this way. If you have 10 variables, we do this way. Gradient f dot u, the unit vector here. I will leave the calculations in the coming lecture, how to find the direction of u, and we're gonna talk more about this section here. Any question here, Shabab? طيب.